In this video, I'm going to describe and illustrate a framework that we developed that can help us in supporting students' approaches to statistical investigations, or the Sasi framework for short. We developed this framework from the Guidelines for Assessment and Instruction in Statistics Education at the K-12 level that was developed in 2007. We further adapted this framework and incorporated more recent research on students' reasoning and the ways that students can be productive in the thinking and the habits of mind that they develop. In this framework, you'll notice that the 4 phases of a statistical investigation are at the center. You pose a question, you collect your data, you analyze your data, and you interpret results. We also have the statistical habits of mind located at the outside in those little mind bubbles that you see. Here we're trying to signify the kind of productive statistical habits that can be useful at each phase in an investigation. Then you see these gradations in color. These help us organize and think about 3 levels of statistical sophistication: level A, B, and C. Now, these levels don't necessarily relate to elementary, middle, and high school, or grades or ages. A student working at any age, if it's their first introduction to statistics, is going to need those experiences at level A. Now, of course, ideally, we're going to have those experiences begin in the primary or elementary grades and allow many extended opportunities for students to develop their sophistication as they get older and as they have more opportunities to engage in statistics. To illustrate this framework, we're going to use an example of a context that I have seen used in middle school through college introductory statistics. Consider typical body measurements that we may be interested in, such as how tall are we? How wide is our arm span? What is our shoe size? If we wanted students to think about characterizing students at their school in relationship to these measurements, how might they approach it? Well, in the posing questions stage, some students might start by asking questions such as, who has the biggest arm span? Does the tallest student have the biggest shoe size? Well, these questions are not statistical in nature. They look for special cases. These questions don't think about the group of students, and they aren't really anticipating variability. So we need to be able to help students move beyond looking for special cases that have a single answer and think about ways of asking questions to characterize groups and to anticipate the variability. For example, I could ask the students to consider the student with the largest arm span and how they compare with the rest of the students in the school. Do they anticipate that there are many students that have the same arm span? Or do they think that our arm spans may be different, or maybe we all have similar arm spans? These types of questions could help the students start to consider group attributes and anticipate variability. Let's consider a few other questions that students might pose. What is a typical height of students in our class? Do boys and girls have similar arm spans? Do middle school boys tend to be taller than girls? These are good statistical questions that consider all the data values. 2 of these questions are explicitly seeking to compare measures from the boys to the measures from the girls. Let's consider how these questions could be categorized into the different levels. For the first one, by asking the question to make a claim about height of students in a single class without seeking any generalization to a larger group, we would consider this a level A. The second question is seeking to compare and account for variability that may exist between 2 groups, the boys and the girls. Thus, this question is a level B that can engage students in beginning to think about how generalization beyond the data may be possible. In the third question, the use of the word tend indicates that there's a goal to seek generalization beyond the sample data, and it hints at the uncertainty in any claim that may be made. This question we would consider as a level C question. So let's go on to discuss different levels of sophistication for collecting data. If the original aim of the task is to characterize middle school students in your school with regards to their height, shoe size, and arm span, students may suggest different types of data collection. Let's consider a conversation among a group of students. The first girl says, "Well, maybe we can survey our entire school. It is the best way." And then a boy responds, "No way. That would take too much effort to survey all our school. Maybe we can randomly select students from each grade." And then the girl says, "Yeah, that is a good idea, but maybe we can just collect data in our class. Maybe our class is not that representative of our whole school." This short conversation illustrates the different levels of sophistication regarding the collecting data phase. For the first girl, she's going to discuss the census of the whole school, so there's no need to generalize. All the data would be available to her. This plan can be considered as a level A in the Sasi framework. Collecting data from everyone that you are interested in. In contrast, for the boy, his idea about randomly selecting and making generalizations from the sample to the population makes this plan to be a level C. But then the second girl starts reasoning at a level that we would consider a level B, when she starts to acknowledge the possibility of generalization from the class to the school. She's also recognizing, though, that there could be a danger in generalizing to the whole school based on a single class of students that are all in the same grade. We're going to narrow in on a particular example of students ages 13 to 14 who are working on this task. The teacher made a purposeful decision that they were only going to collect data from their class. So they came up with a measurement system and directions and methods that they would be using so that everyone was going to measure the height in centimeters using meter sticks, and a method of being able to do that. They were going to measure arm span, again using meter sticks. And then everyone was going to record their shoe size by taking off their shoe and recording the size of the shoe that they had on that day. So let's take a look at the ways that some students might be analyzing their data that they have collected. Students working at level A may make a dot plot of the heights of students in the class. When looking at this graph, they observe that there's one person that seems shorter than all the rest, but that many seem to be around 160 to 166 centimeters. In this way, these students used an appropriate graph for the data, and they compared a special case to the group, and they were informally describing a cluster of cases. They may go on to compute a mean or a median to help in their description of typical heights. Students working at level B could start to compare the distributions of male and females in the dot plots and box plots and make some observations. They may say things such as, "I think boys tend to be taller than girls, though many boys and girls are similar heights, and there's one boy much shorter than all the rest. I'm not sure that measurement is real." Well, moving on to level C, students should be using both graphical and numerical statistics to compare two groups. Students at this level would be coordinating these two types of representations and doing this in a more sophisticated way. For example, they could observe that the mean and the median of the boys are smaller than that of the girls. The range of the boys' heights seems to be bigger than that of the girls. Well, some of these students may wonder if there was something wrong with the outlier that they observe. They realize that there are not any boys in their class who are 121 centimeters or less than 4 feet tall. Some students decide to remove that outlier for further analysis. Other students working on this task seriously consider the extreme case of 121 as the students look around their room and ask, who was that case? They decide to explore the arm span data as well. And when they do this, they notice that when they click on the case of 121 centimeters for the height, that student has an arm span of 178. When they go back to the data recording sheet, they realize that someone had recorded 121 when they in fact were one of the tallest students in the class. As the students discuss this, they realize there was a measurement error in using the meter sticks and that entry should have been 179. They update the data to reflect this new value, and they make different box plots for the height. They observe that the height of boys varies more than the height of the girls, and they use the shading feature to illustrate that about a third of the boys are taller than all the girls. So in the final interpreting results phase, students may also be making claims at various levels. So let's start with our students working at level A. They make the claim that most students in their class had heights that are about 160 to 166 centimeters. They thought this was pretty typical and made sense for students of their age group, and that they still wondered about the realistic value that was so low that they saw in the graph. The students working at level B were making claims that boys tended to be taller than girls. They again thought that this was appropriate for their age range, but that they might expect some little higher variability, and that since their class was in the middle of a 3-grade school, that they might anticipate the same variability, that their class might be representative of the entire school. For the students working at level C, their sophistication was a little bit higher. They were able to very much pay attention to the variability in those boys' heights, and they saw that 35% of the boys were taller than 100% of the girls. This made them really wonder about how representative that class's data could be to represent the entire school. And they were suggesting that in order to really make a claim about the whole school, that perhaps they should select a random sample of students from each grade level and analyze that data further. The Sasi framework is intended to help you structure the ways that you can support the development of your students' statistical sophistication. I hope that this video and the examples that I used in it can help you make sense of the framework, the ways that students might reason at different levels, and help you imagine the kinds of tasks and assessments that you could use in your classroom. I hope you find this framework useful in your own practice.